Hi, today we're going to be talking about segment bisectors. As you can see, we have segment KL, and there's a point M that is on point L, or that is on segment KL. We can see that M is between K and L because they are all collinear, and KM plus ML equals the whole line segment. If this part here, the KM, is equal to ML, we say that this is the midpoint. It's exactly in the middle of the line segment. So a midpoint is a point that is in the center of the line segment. If it's in the center and M is the midpoint, then KM, which is right here, is going to be equal to ML. Okay, so the midpoint does right exactly in the middle, and it makes these two line segments equal. Okay, we have the definition of midpoint. It's in your book on page 94. It says the midpoint of line segment AB is M if they are collinear and this half equals this half. So there's a theorem called the midpoint theorem. And I'll write that down. Sorry, I'm looking at the book and not at the screen. It says if M is the midpoint I'll do it over here, of line segment AB, and I'm just going to draw it over here. So I'm going to have A and B, and I'm going to put M in the middle. So if M is the midpoint of AB, then AM is going to equal half of AB. So that means that if M is the midpoint, that this section is going to equal half of the whole thing. Okay? And they go ahead and they prove that over here on page 94. Let me get that back a little bit so you can see it. So it says here, M is the midpoint of line segment AB. Well, that's what they gave us. That's what we're starting with. Okay? We know that AM equals MB, and they're collinear by the definition of midpoint, because we're given that M is the midpoint, so we know this from the definition of the midpoint. Okay? So from here, they said we're going to go to the definition of betweenness. So AM plus MB equals AB. So basically what they've said so far is this is the midpoint. This segment is equal to this segment, and if we add this segment to this segment, it's going to equal the whole thing. Okay? Then what they've done is they've said, since AM and MB are equal, we can just take AM, the length for AM, and substitute it in for MB, because they're equal. So you can see here, they said AM, they just brought that down. And since these two are equal, they just substituted AM for MB right here, and they said AM plus AM is AB. That's just substitution. I'm going to move that back a little bit. AM plus AM is 2AM equals AB. And then they wanted to get AM by itself, so they divided both sides by 2 and said AM equals 1/2 AB. Okay, so here we have the distributive property and then the multiplication property of equality. So they multiplied both sides by 1/2. And that's how they get from something being the midpoint all the way down to this right here, which is the theorem. Okay? All right. On this page, they say from the theorem you can prove the formula for the coordinate of the midpoint. That M equals A plus B divided by 2. You should also learn the terms bisector and congruent. So basically a bisector, what does bi mean? Bi means two. So a bisector is a curve. It can also be a line. It can be a ray that goes directly through that midpoint. And it divides a line into exactly two equal sections. Okay? All right. Congruent segments right down here. Congruent segments, they have the same length. And the symbol they use is a little squiggle over the top of an equal sign for congruent segments. So here's an example of how we would use congruency. They want to know if CD is congruent to EF. Well, so we would look at CD. We know the distance formula, so we'd say 1 minus -5, or which would really become 1 plus 5. And that would make it 6. And then EF would be 9 minus 3, and the absolute value of that is also 6. Since CD equals 6 and EF equals 6, that means that 6 equals 6, so CD equals EF. They are congruent because they are equal. We would read that segment CD is congruent to segment EF. Correct notation is very important in geometry, so get into the habit of learning and using the correct notation. And that brings us to our exercises. And I will talk about this with you on the phone.